Knowing how quick or how slow a reaction is really important in chemistry. If a reaction is too slow, it might take days to give you the product you want, which wouldn't be very helpful if you're making a medicine. If the reaction is too quick, it could explode. So if you look at this example reaction, in which you have calcium carbonate, marble chips, hydrochloric acid, if you mix them together, they react chemically and you get calcium chloride solution, water and carbon dioxide. So in the lab you will have done this using a conical flask, hydrochloric acid and calcium carbonate chips. As the calcium carbonate reacts with the hydrochloric acid, it makes calcium chloride, which is soluble, so it looks like the calcium carbonate is disappearing. It's not disappearing, it's actually reacting. And you will also get carbon dioxide made, and carbon dioxide gas comes out the top. And there are two easy ways of measuring this. Because carbon dioxide is made as a gas, one of the easy ways to measure it, how fast the reaction is, how quickly gas is made. Specifically, how quickly the carbon dioxide is made. And you do this with a gas syringe. So you attach a big glass syringe at the top, and the glass syringe collects the gas. It's a gas syringe. And the quicker the reaction, the more carbon dioxide is made per minute or per second. The second way you can measure how quickly this reaction goes is if you use a balance. So a balance is like the chemical weighing scales, and if you put this whole thing, the whole reaction, on a scale and it weighs it, what you'll find is that the weight decreases. And the weight decreases because carbon dioxide is being made. And because carbon dioxide is being made and it escapes to the atmosphere, the weight of the flask and its contents goes down. And the quicker the mass decreases, the more carbon dioxide is made per second or per minute, the faster the reaction. So a chemical reaction happens when different atoms or molecules collide with enough energy. So if we look at this thing here, we've got some blue things which are one chemical, and we've got some red things which are another chemical. And atoms and molecules are always moving, and you see these by these black lines. So in this particular box, there's probably going to be only one reaction happening. If you increase the temperature, what happens is the atoms or molecules move around more, and because they move around more, there are more frequent collisions. And it's not just there are more collisions, they are more frequent, which means there are more collisions per second. And because there are more frequent collisions at a higher temperature, the rate of reaction is greater. If you increase the concentration, so in this box here, we've got more red and more blue. If you look, there are more collisions. There are more things bumping into each other, so the rate is higher. If you increase the concentration, it's because there are more atoms or molecules in the same space. Therefore, there are more collisions per second, or more frequent collisions. If we use a catalyst, which is the last one, what we say in chemistry is it decreases the activation energy. Now, you don't need to worry about what the activation energy is for the moment. If you can just accept that there's a thing called an activation energy, and a catalyst decreases that, it means there are more successful collisions. So using a catalyst, there are decreases the activation energy, so there are more successful collisions per second.